think I have my heart rate slowing down, so that's speed walk. All right, so today we're going to continue. We're going to continue with 2.1, and then we're going to get started into 2. No, we're going to continue with 2.3, and then we're going to continue move on into 2.4. So that's what we're going to do today. So this is 2.3 continued. And let's take a look at what we were solving. So our goal, mission, was our goal was, and it's actually, it was, but it still is. Let's change that. Goal is to understand the meaning of life. How about understand the null solutions of, we had A, capital A, Y double prime plus B y prime plus cy equals 0. Is that where we ended, somewhere in there? Okay, we talked about it. And the reason I ask is because I have 2 lectures going through my head right now, and I'm trying to keep them separate, but they just keep wanting to do this. So if all of a sudden things seem to mesh, yeah, you should keep wanting. And, oh, I remember. All right, so here's what we did. So remember we said our goal was this. Try y equals e raised to the st as a solution. So we did that. And what we came up with was this. We took the first derivative of y, and that gave us an s e to the st. Took a second derivative of that, that gave us an s squared e to the st. And we ended with this. So then we said, I'll do this. Let's just do that really quick. That gave us the problem of a s squared e st plus b s e st plus c e to the st equals 0. We factored out e to the st. So we said this is the same as a s squared plus. Okay, that's a terrible choice for s. B, I'm going to have to say it b times s. So b times, just say it fast, you'll understand. Plus c times e raised to the st equals 0. And then our argument, like if we knew that s has real solutions, if there's a real solution, you can make the argument that you can divide by the exponential because it's always not 0. Or you can make the argument that what we're concerned about is when is this first factor 0? So that's what we're going to work with. And so what we did is we solved characteristic equation characteristic equation as squared plus b times s plus c equals And this is what we found. We found that our solution were S equals minus B plus or minus square root of B squared minus 4 times A times C, a big long square root. All of that is divided by 2 times A. So it's just, that's the quadratic formula. That's the quadratic formula that solves the quadratic equation. Okay, so 3 things can happen. 3 things can happen. And like, depending on who your teacher is, like if you have I don't know what you would have. Maybe in pre-calculus, I think, you would spend some time solving this. The key to this whole problem is right here. Does anyone remember what this is called? Yeah, this is called the discriminant. What was that? What's so funny?
Everybody said determinant, and then you said, yeah, this is the discriminant.
You guys are whispering. I don't think I'm not good at whispers. Discriminant. You need to answer both. And so what if it's wrong? We'll fix it. All right, so let's take a look at this. B squared minus, let's see, I'm going to write this one. Cases of the discriminant. Let's do that. Cases of the discriminant. Cases of the discriminant. Here we go. Let's start with B squared minus 4 times A times C is greater than 0. It's greater than 0. Okay? If it's greater than 0, what kind of a number are you going to have? What? Yeah, you're going to have a positive number, right? But what's even more important is you're just going to have some real number. That's all that it matters. If you have a real number here, if you have a real number here, you have a real number here, you add and subtract them, the results are going to be what? You have 2 real roots. Okay? So this gives 2 real roots. I'm just going to call them S1 and S2. And not only that, if I just write S in general like that, it includes both of these solutions. It's this S right here. So if S is greater than 0, what happens? Yeah, the solution is going to explode, and we're going to write the solutions here again so we can see it. Actually, why don't I do that right now? If S is greater than 0, the solution explodes. And I'll write the general solution. The solution explodes. And let's just write the general solution. I'll put it over here. General solution. General solution. This way we can look at it as we progress. General solution is of the form yn. Remember, this is our null solution. It's some C1 e to the S1 times t plus C2 e to the S2. Okay. If these are positives, e grows outrageously fast. So the whole solution is. And what if S is less than 0? What is, oh, actually, explodes. What is the proper word for explodes in this class? Unstable. It's unstable. Okay. If S is less than 0, what happens? It's a stable solution, right? It's going to come to rest. Sure. Okay, we have a stable solution. And it has a name. It has a name. So stable solution. I'm going to put a graph here. Stable solution. The unstable solution aren't even worth graphing. We said it's going to start at, depending on your initial conditions, but it's going to start at some point up here, and then if those are both negatives, it's just going to erase. Does not take very long. Okay. Our next one, if b squared minus 4, oh, let's label this. This is, oh, what was that called? Okay, first off, whenever you have a b term that's positive, b is positive here, b is positive here, the whole system is damped. And so the whole system is damped. Let me put this back. Well, let's make a little annotation. Damp for b greater than 0. The only time, the only example I can think of would be b negative. Did you ever see that Disney movie about Flubber? Did you ever see that? And remember what happened to Flubber? So like, if you ever had a bouncy ball, you know, they bounce pretty high, right? But eventually they come to rest. And you try to catch it, and of course it changes directions. But does anyone remember what happened to Flubber? Yeah, if you drop it here, where would it be after one bounce? Yeah, it'd be higher, right? And then if you bounced it again, it would be even higher. Of course, it was like a science experiment that went wrong, and it came out of it. Maybe the Incredible Hulk came out of it too. I don't remember that, but it wouldn't have surprised me. But that would be b is less than 0. It doesn't really make sense. And if you haven't seen Flubber, has anyone seen that? Yeah. Okay, good. Your silence made me think I had dated myself. What was that? All right, so what do we call this? The solution quickly, remember B represents damping, but there's different kinds of damping. This one we would say is over damping. This would be like the shock absorbers in a race car. It's a really stiff drive. This is why. Why the T. Good. That would be our solution. That would be this. All right, yeah, let's put the N there. Sure, that's a good idea. So what? The next case is b squared minus 4. Really? Jason, say something. 4 AC equals 0. Okay. What happens here? There's one solution, isn't there? And what is, well, actually there's 2 solutions, but they're repeated, right? Because what happens is this whole denominator is just 0, and so your solutions would be minus b over 2a and minus b over 2a. There has to be 2 solutions if you're solving a second degree quadratic. And when we did that, what we found, so it says 2 solutions, or 2 repeated roots is what we call it. 2 repeated roots. And it had a unique characteristic. this was, I'll write that solution. We said our null solution, we said it was C1E S1T plus C2T E S1. Then, let me think what we can. Oh, remember this was the race. This is where T, the race where if S1 is positive, if S1's a positive root, then the whole system is unstable. If S1 is negative, the solution is stable. But remember that for a moment there's a race between T and E to the S1T. And who's going to win? E to the ST, right. E to the ST is going to win, but T challenges it just long enough that you don't really worry about the negative values, but the solution actually comes up, it passes through 0, because at 0, this whole T, well, it can be raised here. We'll come up here, comes up, and then it tries to get away, and then it comes racing back out this way. So we have a picture that looks something like this. Call this one. I should have done that in another color. I have other colors. So we'll make that a pretty blue. This one is called critically named.
Is that a chi-square distribution?
I don't think that's the chi-square distribution. You're right, it does look similar to that with like 0, like just a few degrees of freedom. But no, it's different. It's a different function. Okay.
So having two same, like two real, like same roots, repeated roots, is that everything to do with like those cases that the linear only had eigen values that like you didn't have repeated ones, you could have one next, like all this stuff.
Yeah, kind of. We're going to talk more about that too. Yes, we will. We'll be talking more about that, like the Tacoma Narrows Bridge. We'll see about that soon enough. So hold that one out. So it's a little later.